Hello, this is the third video of the 4-vector series for OCR Pure Core Further Mathematics, and the title is The Equation of a Plane in Cartesian Form. We have already seen in a previous video that a plane can be defined by a given point and a normal vector. Consider a plane with a position vector A and normal vector n then, where a general point is r equals xi plus yj plus zk, and a normal vector n is n1i plus n2j plus n3k. Note that the n1, n2, n3 values give the normal vector whatever the constant value, and all planes with the same normal are parallel. The constant just gives the location, the constant in this case being the scalar product of r dot n. So we would write that x, y, z, in other words r, scalar product with n1, n2, n3, which will give us x n1 plus y n2 plus z n3 equals this constant p for particular values of x, y and z. Sometimes n1, n2 and n3 are given as a, b and c in textbooks. However, the formula book for the exam uses n1x plus n2y plus n3z plus d equals 0. In this example, we're asked to find the Cartesian form of a plane containing a, 1, 2, 0, and perpendicular to 2i plus 5j plus 3k. This is the same example we've used in previous videos, so you are able to compare and contrast the different methods. We know that r dot n equals a, scalar product or dot n equals that constant p. We've seen before that the a with the normal 2, 5, 3 will give us the p value of 12. So we can write that 2x plus 5y plus 3z equals 12 as the Cartesian form, or alternatively we may be asked to write it in this form. In summary then, we can write equations of planes in a variety of ways. A vector equation of a plane in parametric form was r equals a plus lambda b plus mu c, where b and c were non-parallel direction vectors and a was a point on the plane. The vector equation of a plane using the normal was that equation r scalar product of n equal to a scalar product of n equal to a constant p. And now the Cartesian equation of a plane, which may use coefficients a, b and c, so ax plus by plus cz equals p, where p is still that r scalar product of n constant, or n1x plus n2y plus n3z plus d equals 0. Well, you will notice that d is the negative of p. The Cartesian equation can be multiplied by any non-zero constant and still represent the same plane. In both Cartesian forms, the coefficients of x, y and z represent a normal vector to the plane. Here is something for you to think about. There are 6 equations of planes. So, which ones are parallel and which ones are the same plane? You've got those equations of planes formula in the box for you to consider. If they are parallel, they will have the same normal or a multiple of that normal. So in other words, A and B, C and D and F. If they are the same plane, then they will be consistent equations. So you may find that F and C turn out to be the same. I'll leave you to consider all of these for yourselves. In the next video, we will see how to calculate the angle between two planes.